Trigonometry. Good morning. Welcome to TMMS Productions. In this video, we will be using trigonometry to find heights and distances. This was one of the techniques used by the ancient Egyptians to construct pyramids using a simple variation of a protractor.
So, in this heights and distances, the terms used are line of sight, angle of elevation, and the angle of depression. So, what is line of sight? If a person P is standing at a point and he is looking at a tall object, then the imaginary line joining the tall object and the observer's eye, this is the line of sight. Now this is an imaginary line. So we understood what is our line of sight. Now what is the angle of elevation? If the body is at a height, which means it is at a higher level, then the angle made by the line of sight with the horizontal, this angle, let's call it as theta, that becomes the angle of elevation. So angle of elevation is when the object is at a higher level than the person, the observer. What is our angle of depression? When the object is at a lower level. So the eye of the person and the line of sight. So when he is looking below the line, which is horizontal line, it is at a lower level. Then this angle made with the horizontal by his line of sight, we will call that as alpha. That becomes the angle of depression. So what are our terms? Line of sight, angle of elevation when we are looking up at the taller object, and angle of depression when we are looking below the line of sight, when we are looking down. Now we use the information that we learned to solve the problems which are presented to us. Let us look at our first question. Number 1, the length of the shadow of the tower is 1 upon root 3 times its height. Find the angle of elevation of the sun. Now in order to solve this, first of all we have to look at the tower, which will be vertically upwards standing on the ground. So we draw the diagram like so. This AB becomes the tower and BC becomes the ground. Now the sun is shining somewhere here and the rays of the sun will be blocked because of AB, and what we will get are BC as the shadow. Now our diagram is appropriately drawn with this showing 90 degrees, so it becomes a right triangle. Now they are asking us to find the angle of elevation of the sun. Angle of elevation will be this theta. So now we look at the length of the shadow of the tower, that is this length BC, is 1 upon root 3 times the height. So we call this height as x meters. Then the shadow becomes 1 upon root 3 times its height. And so we connect this theta with AB and BC. AB is opposite, BC is adjacent. So AB upon BC gives us tan ratio for this theta. And so we write tan theta is equal to AB upon BC. Now AB is x, upon BC is x upon root 3. That gives us x multiplied by root 3 upon x, which cancels this x and you will get root 3. And so we will have tan theta will be equal to root 3, but root 3 is nothing but tan of 60 degrees. Remember to watch my earlier video where I have spoken about the ratios of the standard angles. 60 degrees is a standard angle and we know how to calculate the ratio by looking at the table or simply looking at your hand. You can watch that video to understand how to get that value. So now if tan of theta is equal to tan of 60, then theta becomes 60 degrees. And what is our theta? It is the angle of elevation of the sun, and that is 60 degrees. So we have our answer. Let us come to question 2. Two men standing in front of a tower 200-meter tall. Observe the angle of elevation of the tower to be 40 degrees and 70 degrees respectively. Find the distance between the two men. Now here also we have to draw the diagram in order to understand the question better. So we have this vertical line, we'll call this as AB, and this will be our 200 meter, that is the tower, 90 degrees with the ground. So this is the ground level. We shall call this and this as C and D. So we have the two observers who are looking at the top of the tower. Now the angles of elevation that we have 40 degrees and 70 degrees. So we will have this one 40 degrees and this one will be 70 degrees. As we come closer, the angle of elevation increases. So now that we have this, we will have two triangles, ABC, which is the first right triangle, and ABD, which is the second right triangle. And we are expected to find the distance between the two men, and the distance between the two men is from here to here, and this is our X. This is what we have to find. So now, how are you going to connect this CD with the right triangles? This triangle ACD is not a right triangle. So we need to take ABC and ABD. And CD can be connected with BC and it can be connected with BD. So you will see that if I find the value of BD and I subtract the value of BC, then I can get CD. What will be CD? CD will be BD minus BC. So now we'll have to take firstly triangle ABC, which is the first right triangle, and then we'll have to take ABD, which is the second right triangle. So in right triangle ABC, I would take tan of 70 degrees. For 70 in this triangle ABC, opposite is AB and adjacent is BC. So we'll write it as AB upon BC, which means tan 70 degrees is equal to AB is 200 upon BC, and therefore we will get BC equal to 200 upon tan 70 degrees. Now let us look at our second right triangle ABD. In right triangle ABD, we will have 40 as the angle of elevation, which will have AB as opposite and BD as adjacent. So that will give us the tan ratio. Tan 40 degrees is equal to AB upon BD, which means tan 40 degrees is equal to 200 upon BD, and that gives us BD equal to 200 upon tan 40 degrees. Now, if you look carefully, at the tan table, you'll have to use the log table and get the value of tan 70 and tan 40. Now tan 70 is going to be a decimal number. So you will have with 4 decimal places one number here to divide 200, and here it will be another number with 4 decimal places to divide this. So when we are loaded with a situation like this, we do not use this method. We do not take tan 70 and tan 40, but instead what we do is we take the complement of 70, that is this. So in triangle ABC, we will not take tan 70, but we will take tan 20. In ABD triangle, we will not take 40, but we will take the complement of it, which is going to be 90 minus 40, which is 50 degrees. So let us see how we proceed with that. So we have in right triangle ABC, you can see ABC, we will not take 70 but we'll take complementary, that is tan of 20 degrees will be equal to, for 20 opposite is BC, and we have adjacent which is AB, and therefore we will have tan 20 degrees will be equal to BC upon 200. And so we will have BC equal to 200 tan 20 degrees. So tan 20 degrees is multiplying BC. Now tan 20 is 200 multiplied by tan 20 is 0.3640. Now let us look at the second triangle. In triangle ABD, we would take now not tan of 40 but tan of 50 degrees. So tan of 50 degrees is equal to, for 50 opposite is BD and adjacent is AB. And so we will say therefore tan 50 degrees is equal to BD upon 200, and therefore we will have BD equal to 200 times tan 50 degrees, which is going to be 200 multiplied by 1.1918. Now we are interested in not BC or BD, but we need CD. And so we are going to say therefore CD will be BD minus BC, which will be 200 multiplied by 1.1918 minus 200 multiplied by 0.3640. That will give us 200 into bracket 1.1918 minus 0.3640. That gives us 200 into bracket, we subtract this and we get 0.8278. That gives us 2 multiplied by, I'll use these 2 zeros to shift the decimal point, so 82.78, and that would give us 165.56, those many meters, and that is the distance between the two men, and that is our answer. So in this question, what did we learn? That if we take the angle of elevations the way they are given and we use their ratios, we are going to get a number which will be very difficult to calculate because we are not given calculators for our examinations. So we need to know a nice way where we will have easier calculations. So remember, anytime we have something like dividing by this big number, this will be a 4 decimal place number, and this one also 4 decimal place number. So when we have something like this, we will just strike this and we'll say please omit. We will strike this and we'll say please omit, and then we will take the complementary angle as I have shown you here. So when we take the complementary angles, instead of 70 we took 20 degrees, and then we got a good number to multiply is easier than to divide, and then for 40 degrees we took 50 degrees of the same triangle, and now we got the two numbers, that is 200 and this 1.1918 were to be multiplied, and then you saw the calculations were easier. Okay, so let us come to the third question. But understand that I have done this question with the same type of diagram in my earlier video where we have the trigonometric solutions of 2D problems. So 2D problems have easier numbers like 60 degrees, 30 degrees, 60 degrees, 45 degrees. So you can watch that video for the easier angles. Here I have taken deliberately where you will learn to apply your mind for something that is not as easy. Let us come to the third question and the last question for this video. A man at the top of a tower 100-meter tall, so we've been given the height of the tower, observes that the angle of depression of a cycle on the ground is 13 degrees and 54 minutes. Now here deliberately I didn't give you an easy number like 30 degrees or 45 degrees or 60 degrees, because you need to know how to use these angles as well. For simpler values and only the diagrams of something similar to this are already in the earlier video of simple 2D problems, the solutions of them, which I put up some time ago. So do look at it before we come to the problems. Now for your level, it will be for 10 standard, it will be the word problem which has to be converted into a diagram. In that earlier video, we have the ready diagrams and then you have easier calculations. Here you'll have to draw the diagram, understanding the concept. So find the distance of the cycle from the ground where the foot of the tower rests. So as usual, you can see that there will be a tower. So there will be a vertical line, there will be ground, and there will be horizontal, and then the angle of depression where the cycle will be. So let us draw the diagram. So as usual, we will have a right triangle. We will call this as the tower, and this will be our ground, and this will be your cycle. Now, because there is angle of depression, which means I'll have to show horizontal, and then the line of sight will be below that horizontal. So this angle over here, this is 13 degrees and 54 minutes. Now this angle is outside the triangle, so we use the property of alternate angles. We have this parallel to BC, and so we'll have alternate angles formed. So this angle also is going to be 13 degrees and 54 minutes. So we have, for this angle of triangle ABC, we will connect with the tower and will connect with the distance of the cycle, which means tower is AB. How much is the height of that? Can you see? It is 100 meter. And so we connect 100 meter with this BC. Now let us see how we proceed with that. Again, we will start with in right triangle ABC, and we will take the angle C, for which AB is opposite, BC is hypotenuse, which means AB upon BC is the tan ratio. So tan of 13 degrees and 54 minutes is going to be AB upon BC. And so tan of 13 degrees and 54 minutes will be 100 upon BC. Now BC will be equal to, therefore, 100 upon, now BC comes here and tan goes there. So we have tan 13 degrees and 54 minutes. Now, can you see that this particular number again is going to be a number which will be not a very friendly number? So you are going to have a 4-place decimal. It is 100 upon 0.2475. Let me just put it here. Now, are we going to sit and divide with this 4-digit number? So what we are going to do is, like how we saw in the earlier question, if we have a number like this dividing an easier number, in other words, if the calculations are kind of difficult or weird, then you will not use this method, but instead what you will take is the complementary angle. So I'll just write over here, please omit for the examiner, and then I will find this angle. Now this angle A is going to be 90 degrees minus 13 degrees and 54 minutes. Now some of you may have a little confusion regarding how to subtract this. So I'll just show you the steps and I'll put them in bracket. Now this 90 degrees we will write as 89 degrees and 60 minutes. Remember, each degree is divided into 60 equal parts. And from that we will subtract 13 degrees and 54 minutes. And so what we will get is 60 minus 54 is going to be 6 minutes. And then 9 minus 3 is 6. And 8 minus 1 is 7. So 76 degrees and 6 minutes is our angle here. So I shall write this as 76 degrees and 6 minutes. So now in order to get the numbers which can be multiplied with rather than dividing like so, we will use the tan of 76 degrees and 6 minutes. And that will be equal to, for this angle, opposite is BC and adjacent is AB. And so we will have tan of 76 degrees and 6 minutes will be equal to BC, which we have to find, upon AB, which is 100. And that would give us BC, therefore, is equal to 100 multiplied by tan of 76 degrees and 6 minutes. Now, whatever is the value of tan of 76 degrees and 6 minutes, we will find it and it will be 4.040 from the log tables. I found it. Now with this 100, I'll use these two zeros to shift the decimal and then I will have to shift the decimal like so, and I will have 404.0 meter, and that is the distance of the cycle from the foot of the tower, and that is our answer. So I hope you found this video helpful. Thank you for watching.